Okay, this session is going to be looking at using graphical skills. You can be asked to look at and interpret a range of geographical skills according to the specification. The key thing that you're being asked to actually look at really is to be able to construct and complete them, and then be able to interpret them and think about their various advantages and disadvantages. So what we're going to look at over the course of this video is a series of advantages and disadvantages, series of video ideas, advantages, disadvantages, and various other things. Okay, first up and foremost, we've got the different types of data. This is important to remember because it actually helps you when you're thinking about the way of analysing it. So first off, we've got our types of data. This is data which can be tracked over time or distance, for instance pebble size in a river or a long longshore drift. Otherwise you've got non-continuous data. This is data which is distinct from each other. An example of this is the questionnaire results which you do at various different points in times. Now the current year 11s did it in Seaford, the current year 10s did it in Docklands, so you've got these different types of data. That's non-continuous because it's not going over a continuous period of time or a continuous distance. So let's have a quick look at a range of different graphs. This is a line graph. You should be very familiar with this. Key thing is a line graph will show continuous data along the bottom, and then it shows trends and variations in this. This is in looking at number of dolphins, but it could be showing anything, to be honest. And you can read that and figure out your own patterns from it. This is a different type. This is scatter graph. This shows two variations and between two different factors, and it's looking for correlations. You can see patterns very easily on this. Very often you end up drawing lines of best fits to actually join the points up, but because each point doesn't relate specifically, you wouldn't draw a line to connect them up, you just draw the line of best fit. Okay. Then we've got pie charts. Pie chart, very simple chart, shows percentages, very easy to construct, easy to read, easy to see patterns, unless there's too much information, in which case they can become quite complicated. And often you'd lose the numbers because they don't show the exact figures. This is a very complicated type of graph. This is a triangular graph. You get these occasionally where you want to show the relationship between three different groups of percentages that you have data for. And that allows you to actually see and plot different types of patterns. Quite unusual, but you do get them from time to time. We drew these when we were at Seaford and when we were in Docklands with the year 10, and these are our rose diagrams. These allow us to look at a large amount of information and see patterns between them. You can also use these so that they're pointing in directions, so you can see where things are coming from and the proportion things are coming from as well. Then we got onto types of maps. This is a choropleth map. This shows proportions of area, and it allows you to see patterns very easily. This is a map showing patterns of water withdrawal, and when you look at this map you can see that the highest water withdrawal is in areas to the south and to the northeast, where you've got different areas. Okay, and you can see those patterns quite clearly. The least is running down the middle. You're not going to be asked to explain that, so be wary of that. Don't start saying because most of the people live here, because that's true, but it's not answering the question. These are proportional circles. Again, these are infrequent, but they're a good way of showing large-scale patterns. Problem with them, it's difficult if you end up with too many circles to actually tell the difference between sizes. Next up, we've got a very simple type of graph. This is a bar chart. You should be very familiar with these. You need to have separate data to be able to show this. You can show it over time, but it's unusual. The graph in the bottom left works much better for it. Okay. You've drawn these before. This is a histogram, which is showing continuous data over time. The population pyramid in the bottom right hand corner is an example of a histogram. They can be very difficult to read unless you know what you're looking for. The graph on the left is a double axis graph, and you can see temperature patterns both on the right hand side, and then you can see rainfall patterns on the left hand side. But if you don't read that graph quite right, it becomes quite complicated. Isolines, which join up areas of continuous data. They can't cross, and you can see the patterns relating to that. This one's relating to temperatures. These are flow lines. This is a very complicated flow line map. And you can see the problem with this because you just end up very, very confused. The only things you can tell easily are the fact that Germany, France and the UK have a lot of flights going into and out of them. From that point on, working out actual figures becomes very, very difficult. And then we get to an exam question. This is from the June 2011 paper, and which some of you will have seen before, to be honest. And then you get a scatter graph here, and what they're going to ask you to do is, the first thing they asked you to do was plot points 7 and 8. No, there's no line on this, you've just got to cross those dots. Make sure you cross them accurately. And then what you're going to get is a couple of questions. A, give one reason why a scatter graph is a good way of displaying this type of data, and if you think about it carefully, you make a point and then develop it. So a scatter graph is a good way of displaying the data because it allows you to see patterns and you can see any trends and anomalies very easily. So there's two separate points, but making the same point developed. Okay, and then this question, if you get a question like this, should be your friend. Describe how the width and depth changes as it flows from site 1 to site 10. Use data in your answer. As long as you use the data, you will be absolutely fine, and just write as much as you can about all those different points and the variations.